Today we will study about the stationary waves. So stationary waves, these are the waves which are moving in the opposite direction with the same velocity and same frequency and wavelength in this way, and this is the opposite direction of the wave in this way. These are the stationary waves moving in the opposite direction with the same amplitude, same wavelength, same frequency and same velocity. So these are the stationary waves. Today we will study the case when the stationary waves are in the pipe open at one end. Stationary waves open at one end or closed at one end or open at one end. So this is the case. So as we know that the equation of the wave is y dash is equal to r sine 2 pi upon lambda vt minus x. This is the equation of wave when it is moving from left to right with the velocity v and wavelength lambda. If the origin is shifted, for example, it is O and this is O dash. Origin is shifted to O dash. Then the equation of wave will be R sine 2 pi upon lambda Vt plus x. Okay. And after reflection, as we know that after reflection what happens, the direction of the wave is reversed and a phase change, this is very important, phase change हो जाता है equal to pi. Okay, so the equation of wave will be minus r, it is due to the phase reversal, and sine 2 pi upon lambda vt plus minus x. This is equation number 2. Now, according to superposition principle, what will happen? Y is equal to y dash plus y double dash. So we will find y is equal to r sine 2 pi upon lambda vt plus x, and plus, but the sign is minus, r sine 2 pi upon lambda vt minus x. So we will use a formula here, that is sine c minus sine d, okay, which is 2 cos c plus t upon 2 into sine c minus t upon 2. So when it is applied, the net displacement will be equal to 2r cos c plus t means 2 upon lambda plus it will be vt and sine 2 pi upon lambda into x. So this is your final equation, and the amplitude will be y dash will be equal to a into cos 2 pi upon lambda into vt. Okay, and what is a? A is the amplitude of the final wave after the superposition of two waves. A is equal to 2r sine 2 pi upon lambda into x. Now we will find the condition. As we know that at x is equal to 0 means the amplitude will be maximum. Okay, amplitude will be maximum means equal to plus minus 1. As we know that in this wave, this is amplitude and maximum at plus 1 and minus 1. So these are the constant things, only sine angle is variable, and in place of x I will write here x is equal to L. At x is equal to L, it will be having maximum. So sine 2 pi L is equal to plus minus 1. and sine is plus minus 1 at when the angle is equal to pi by 2, 3 pi by 2 and so on up to. Means generally we can write here 2 pi upon lambda into L is equal to 2n minus 1 into pi by 2, where n is equal to 1, 2 and so on up to n. So here we will find that L will be equal to 2n minus 1, pi will be cancelled up and lambda by 4. This is the final condition which will be used to find the various modes of vibration. So this is the condition, L is equal to 2n minus 1, L upon 4. Now for first mode of vibration, first mode of vibration, we will put n is equal to 1. So we will get here L is equal to, it will be equal to, lambda upon 4. It means that the complete length of the pipe will have lambda by 4, 1 by 4th part of the wave. So I can draw the graph 1 by 4th, as we know that the complete wave is in this way. This is the complete wave. Okay. So means this is the 4th part, 1 upon 4. So I can write here in this way, this is the incident and this is after reflection. In this way, this is the diagram for the first mode of vibration. So we will put here V is equal to lambda into nu 1, because we are doing for the fundamental or first mode of vibration. So here I will get here L is equal to, in case of we will get into 4 nu 1. This implies that nu 1 is equal to V upon 4 into L. This is the first mode of vibration, and it is clear that here nodes, this is node and this is antinodes. So nodes are nodes equal to 1 and antinodes. Antinode is equal to 1. What are nodes? Nodes are the points on the wave at which the displacement is minimum is 0, and the antinodes are the positions at which the displacement is maximum or amplitude is maximum. So we have only one, and in this only one. So this is the first mode of vibration, also called the fundamental frequency or first harmonic. First harmonic. Okay. And the same for the second harmonic, second mode of vibration. Here we will put n is equal to 2. So we will find here L is equal to 2 to the 4, means 3 lambda upon 4. Okay. Now it is clear that now we will have, this is the total length, and 3 by 4 means 75% of the wave. So I can write here in this way, this is the 3 by 4 in this way, and this is the incident wave, you can say, and after reflection it will be in this way. So this is the for the second mode of vibration, and you are finding here that there is 2 nodes and 2 antinodes. But before that we will put the value of V, nu 2, V into lambda into nu 2. So this implies that L is equal to 3 lambda will be replaced by V upon 4 into nu. This is 2. So this implies that second frequency will be equal to 3 V upon 4L. So this is the second mode of vibration. So you are finding here that nu 2 will be equal to 3 into nu 1. It is clear that nu 2 is equal to 3 into nu 1 after comparing with this, because this is 1 upon 4 and this is 3 upon 4. So here we can write here in this way. So for the third mode of vibration. So here we will put n is equal to 3 and 3 to the 6. We will find here that L is equal to 5 lambda upon 4. So means 1.25. Now it is very much clear. I will tell you. This is the one wave, and this is the 1.25. Okay, in this way you can find here. But L is there, so I will draw the diagram in this way, because the opponent is in this way we have taken. So x is equal to, so you will find that in this way, and this is the 1.25. Okay, and in this way you will find it. So 1, 2, 3 nodes and 1, 2, 3 antinodes. So in this case, nodes is equal to 3 and antinodes is equal to 3. In this way you can find, and we can write here the value of nu 3. L is equal to, V is equal to lambda into nu 3. So putting the value of lambda in this equation, L is equal to 5 upon 4 into V upon nu 3. So this implies that nu 3 will be equal to 5 upon 4 V into L. So here it is clear that nu 3 will be equal to 5 into nu. So the ratio will be nu 1 is to nu 2 is to nu 3 is equal to 1 is to 3 is to 5, unlike that of the stationary waves in a string fixed at both ends. In that case the ratio of frequency was 1 is to 2 is to 3, but in this case it is 1 is to 3 is to 5. नोट कर देनी है